And now we come to the more challenging questions when they give us the value of one expression and another expression, and they ask us to find the value of the third expression. In this case is x squared plus y squared. Now, a hint is to start from what you've learned before, your three algebraic identities. And for question 1, we have already spotted one identity here, x plus y whole thing square. So I'm going to write down the identity and see what we can do with it. I have rewritten down the first identity, and I know my x plus y whole thing square is 38, and my xy is negative 24. So I will substitute all my known values and later find for my x squared plus y squared. So my x squared plus y squared is simply 38 minus 2 times negative 24. Answer is 86. Second question is similar, but for the second question, I have a new identity to use, a minus b whole thing square, which is the minus case. But same thing, they also give us the value of another expression. AB is negative 51. And they ask us to find the value of a squared plus b squared. So for question 2, I will first write down the second identity and then substituting my known values before finding out what I want, which is a squared plus b squared. And this answer is 194. Now we come to this last question, which is the most complex one. First part, explain why 2n plus 1 is an odd number. And to explain this, we shall use the help of even numbers. We can see that 2n is an even number as it's divisible by 2 or it's a multiple of 2. And hence, because of that, whenever you add 1 to an even number, it will always give you an odd number. So 2n plus 1 will be an odd number. Second part, write the expression for the next odd number which is greater than 2n plus 1. This is very simple. If I by first odd number add 2n plus 1, how many more must I add to get the next odd number? I need to add 2. So the answer would just be 2n plus 3 is the next odd number. Part 3. Find and simplify the expressions for the squares of the two odd numbers. What it means is to individually find the squares of each of the number and simplifying the expressions. And since we have just learned identities, we can make use of one of them, which is we can use number 1. Of course, take note that we are using the expansion identity, which is from the right to the left. The answer would be this. And now I have my expressions for the squares of two numbers, which are odd. Final question, part 4. Hence, explain why the difference between the squares of the two consecutive odd numbers is always a multiple of 8. Before we actually look at why is it a multiple of 8, let's just find the difference first. We shall focus on that. The difference of the squares. Simply, I will take the bigger number 2 minus the smaller number 1. And with the answer from our part 3, we can use it to help to simplify. I realize some terms will be cancelled out, like my 4n square minus another 4n square. My answer would be 8n plus 8. Is this enough to show that it's a multiple of 8? I actually need to move one step further and factorize out the 8. And by showing this step, I have actually shown that the difference will always be a multiple of 8. So only with the last step, I am done with showing that it's a multiple of 8.